Hey ladies, here are the answers to the even and the odds that are also in red from your homework assignment. Don't forget to submit those after you figure it out. I'm sure, I can't imagine that you didn't have any trouble with this assignment. It was very simple. Remember distance and displacement, yada yada. Okay, I would expect you to check the Riemann sums with the program just to get used to that as well. All right, part 2 of your fundamental theorem of calculus is nothing that you haven't seen before. Here it is, how to take an antiderivative. Remember, the first part says the derivative of an integral is the original function. This is the second part. So let's just dive right in. Let me get rid of this. We are going to evaluate using an antiderivative. So what's that? X cubed over 3 plus x from 0 to 3. Evaluate it. That's the F, big F antiderivative we're talking about up here. Then we just plug in our 3, 27 thirds plus 3 minus 0. So what do we have? 9 plus 3 is 12. Okay. Squared plus 1 is right here. From 0 to 1, 2, 3 certainly is all positive. That makes sense. I'm not going to check with my integration quite yet. Okay, here's the function. So I'm going to do my antiderivative, negative 4x to the 4th over 4 minus 8x squared over 2, negative 1 over 2, negative 1 to 2. All right, let's reduce. Negative 1, sorry with these black lines, I just can't control them. They just kind of do their own thing. Minus 4x squared from negative 1 to 2. All right. Negative 1, x to the 4th would be 16. Sheesh. Minus 4, 2 to the 2nd is 4. That's negative 16 minus 16. Sorry, that's so messy. Minus, we're going to plug in my negative 1 now. That's negative 1 minus 4, which is negative 5. Okay, negative 16 minus 16, negative 32, negative 27 total. Okay, and that one is a little bit misleading because I've got this. It should be bigger because these are by 2, so it doesn't look right. But if it was not, if it was scaled differently, this part would be way bigger than these two pieces together. So that's why it's negative. Okay. All right. I did check it. I think they're in here. If you don't trust me, here's the first one. I know you trust me. Here's the first one. Here's the second one. So don't forget, you can check your integration. Okay, so g of x is this, where f is the function. This is f that we're looking at in blue here. Well, then I should write that in blue maybe. Okay, so this is f. G prime, yikes, is going to equal f of x, right? If you look at this, g prime is going to be f of x. All right, so at what values do the local max of g occur? Remember, local max occurs where g prime changes from positive to negative. Okay. So f of x is sitting right here. All right. So the local max, if we look at f of x, it changes from plus to minus right here, changes from minus to plus right here, changes from plus to minus right there, changes from minus to plus right there, and that's it. This, we don't know what's happening over here, so it's not changing. Same with here. It didn't really change. Okay. So local max is at x equals. Okay, where did it change from plus to minus? At 2. Plus to minus at 6. Okay, local max, local min, sorry. Remember, min is where it changes. And when I say it, G prime. From negative to positive. All right, local min, negative to positive. That would be at 4. That would be at 8. Okay, so those are my local max and min. You got to just remember this is the first part, G prime. That's the first part where you just plug in your X, okay? And then that's your F of X that you're looking at right here, okay? You kind of just got to wrap your head around it. It's just a weird thing. Okay, and what intervals is G concave, where G double prime, remember, is negative. Okay, so G double prime is going to be F prime. Remember, we're looking at F. So if we're looking at F prime, we are going to be looking at the slopes. So the slopes of these are positive, 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 positive. We get to here. And then negative, 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 negative till we get to here. And then positive, 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 positive till we get to here. Negative, negative, negative till we get to here. Positive, positive till we get to here. Negative, negative. Okay, so we want all the intervals where it's negative. And I'm talking about G double prime. That's in red up here. So I'm talking about from probably what? 1, 2, 3. Oh, gosh, it's a crazy thing. All right, 1 to 3. Again at 5 to 7. Just does whatever it wants. And 9 to 10. That's all we know about. We don't know what's going on after 10. Okay, so you have to use the interpretation that we did before to get that. All right, let's try another one. Concave up. All right, so we're starting from the beginning. That's where y double prime, if y is concave up, y double prime is positive. All right, so y prime. First part of the FTC is plug this in. So y prime is x cubed minus x. Y double prime is regular derivative, 3x squared minus 1. Okay? All right, if we want concave up, we want to know where this is greater than 0. So let's start with 0. Get our critical values for concavity, our possible inflection points. 3x squared equals 1. X squared equals 1/3. X equals plus and minus 1/3. Okay. All right. So we have to do inflection. Check out our negative radical 1/3 and our positive radical. Wow, 1/3. I swear I'm not doing anything with that black stuff. Okay, so 0's somewhere in between. We're going to be checking out. Whoops, it's y, isn't it? I didn't want to do that. All right, y prime. We'll do y double prime, double prime, double prime. All right, so remember, I don't know what these values are, but I do know that this is going to give me something like this. All right, I know 0's in the middle of it. Okay, so here's my radical 1/3. Here's my negative radical 1/3. Okay, so from here, it's positive because it's above the x-axis. On here, it's negative and positive again. Okay. I don't know what these values are. I can look up on my calculator, but I really need to know them. I just need to know that the graph looks like that, and these are going to be positives, and in between right here, we're going to be negatives. Okay. So I'm looking for concave up. So I'm looking for positives. So concave up on negative infinity to negative 1/3. And again, positive radical 1/3 to infinity. Okay. So that should be good. You should be good to go.